So, cool. So, that's the action potential, right? That's myelin sheath, that's nodes of wrong VA right there. But what happens after the action potential? We get something called a refractory period. Refractory period. Remember, all the sodium ions have entered the cell. Yeah? All the sodium entered there? That means like the battery is like depleted. So we have to recharge the battery again. We have to get the sodium ions back out. In other words, the sodium potassium pumps, making the sodium ions that are inside the cell go back outside to reestablish this thing. Okay? We got to recharge the battery. Okay? This happens 1,000 times per second still. It's a fast process. But we have to recharge the battery. That's the refractory period. Because remember, all the sodium ions are now inside. We've got to pump them back out to get back to resting potential. But it's such a fast process. A neuron can fire 1,000 times per second. So the refractory process is very quick, but still, during that refractory process, a neuron cannot fire. Cannot fire whatsoever. Okay? So that's our next event right there. Does that make sense? Right? That's why I go so like heady on like the ions and stuff, because now you understand, oh, that's what it means. I know where the ions are moving. If you know where ions are moving, you kind of get it. Next thing. Oh, I love my new slides. Okay. I stayed until 2 in the morning making this pretty. You should have seen this before. They were so bland. It was just all words. But I'm like geeking out right here. A little bit faint as well, but I don't care. We did the electrical part, right? Now this. Remember, communication is electrochemical. Now we're going to do the chemical communication, right? Neurons are not physically connected. They're not joined together. Like our islands were not joined together, okay? Therefore, they have to pass a signal across this physical space known as the synapse or synaptic gap. Boom, boom. Yeah, yeah, yeah. So people, mind the gap. Mind the okay. Okay, I should have committed to the joke, though. Mind the gap. Okay, it's all about the gap, the synaptic gap. Okay, that's what I'm talking about right there. All right. So people, we're talking about the chemical part. Look up through the video. Right here. Okay. Okay, you are your synapses. Neuroscience says it because this synapse is where all some of the magic happens too. Neurotransmitters. Look, these red things opening up, allowing something to go into the dendrites. I wonder what. Let's see it again. Neurotransmitters, right? The chemicals. They lock onto here. These red things, boom, open it up. The red things don't go in. These blue things do. What do you think these blue things are? Sodium ions. Those are sodium ions, right? Neurotransmitters, that chemical process allows for sodium ions to enter, that depolarization, okay, in the beginning. So, how about another video to explain, huh?
If we look inside the terminal, there are small sacs or vesicles.
These are their toes.
Chemicals called neurotransmitters.
The chemicals.
For this example, we'll focus on acetylcholine, one of the major neurotransmitters in the brain. When an electrical impulse arrives at the terminal, it signals the vesicles to move toward the terminal's membrane. When the vesicles reach the terminal membrane, they actually fuse to it. Once the membranes of the vesicle and the terminal are fused, the vesicles release acetylcholine out into the synaptic space.
This is inside the axon
This
terminal bud.
process is called exocytosis.
Exocytosis, okay? Exocytosis. Important word to know. Here, right here, look. This is
If
underneath.
you look at the terminal from below,
In the synapse.
you can see the acetylcholine being released
Whoa.
from the vesicles into the space underneath the terminal.
The terminal buds squirting out across the synaptic gap, right? Oh my gosh.
However, the release of neurotransmitters such as acetylcholine is only half the story.
So now they diffuse out into the
Once a
synapse.
neurotransmitter is released, it needs to do something.
Okay, they don't have minds.
Let's
Just
view this
diffusion.
sequence of events.
So
once
action
more.
potential
An electrical impulse
potential.
moves down the axon toward the terminal.
makes the vesicles
It
move.
signals
Literally.
the vesicles to release acetylcholine into the
Transmitters?
synaptic
Chemicals?
space.
Dendrites, right?
Now, once the acetylcholine is released from the nerve terminal, it binds to special proteins in the receiving cell called receptors.
Okay, receptor
This
channels.
binding of acetylcholine to its receptors causes a channel to open and sodium ions to move into the receiving cell.
Right?
As these positive charges enter the cell, an electrical current flows across the membrane.
Depolarization.
When the neurotransmitter comes off the receptor, the channels close and the current is turned off.
So neurotransmitters are the things that make depolarization happen on the dendrites. Okay?
So nerves talk to each other using...
So I'll stop here because I want to explain it myself, right? Neurotransmitters, NTs are like this. They're a key. They're a key. Okay? Exocytosis triggered by action potential. First, that's how neurotransmitters are released. So I'm going to need some help here to explain exocytosis one more time.
Volunteer?
Please. How about this? Okay. Moss. I need 8 volunteers. 8 volunteers. Come on up. Don't raise your hands. Okay, just come on up. Come on up. Yes. Good. Come on up. Yeah. 3, 4, 5, 6. I need 2 more. Dom, thank you. And then yeah. So let's go 9. Let's go 9. Yeah. Let's see. You guys can make a line like Red Rover right there. Red Rover. Hold hands. Hold hands.
We got 9 now.
Okay, hold hands down right here. Yep. This good. And you right here. Stop. I want you to make a circle, holding hands right here. Circle right here.
Plus
You,
5.
yeah, you 5 right there. Boom. Hold hands. Super awkward.
Oh, that's for Nate.
Nate, what's your middle name?
No.
Let's say it's Tiberius, shall we? Oh, what a coincidence! Nate Tiberius Miller, NT, neurotransmitter. Neurotransmitter, get inside your vesicle. Alright. Get it? Okay? This is the axon terminal bud, your ptosis, right? Your toes, right? Okay? Over there is the end of the axon terminal wall. Where are you at? Woot woot. Okay? Guess what I am? Caffeine. I'm action potential. Okay? I run down the what? I'm running down the what? Axon. Thank you. I get to the axon terminal bud, and literally, this is what happens in the biochemistry. The energy actually zaps the vesicle, and it makes them move. Okay, so shake it out, walk it out. Yeah. Okay, so you guys are moving, right? You guys are moving that way. You're moving to the wall, and moving to the end of that axon terminal bud. Moving. And stop. Who is this guy again?
The neurotransmitter.
Now, break right here. No. Yeah, hold on. Now you hold Sophia's hand. You hold Dom's hand. Then Dom. Yeah.
Wait,
No. One more. This is the middle one.
No, there's one more person.
The middle one, right? There you go, like that. Okay. Now, Dom, follow me. Look, fusion with the wall, and then guess where NT can release into? The mind. Go to the receptor. Yes. That's exocytosis. Yeah. Do one. No, you're not done. Rewind. Go back. Okay, get ready. Come back. Okay, go back in. Okay, here we go. Who wants to explain this? Who's got this? Wants to explain this? Okay, I'll explain this. Rachel. I'm going to do it. Just tell me what's happening. Can you? I want to help Rachel out. Just yell it out. Ready? Go.
Action potential.
Okay.
Vesicle.
Okay. We're the terminal bud, right? Now all of a sudden, fusion. They hit the wall. Exocytosis. And then, Nate Miller goes where? Touchdown. Take a seat. You just got exocytosis. In mitosis. Get it? In mitosis, which are your terminal buddies. Right? Say, look.
Well, what are you, like, I know that you were action potential, but what were you running down through the action?
Literally, I was at sodium ions going in and out. We saw that wave on the axon. The electricity. We consider it now as electricity going down.
Okay.
Actually, if I gave you guys balloons and made you do static electricity on your head right here, and I made all of us do it, right? We're charged. If I made all of us run through this door, technically we are considered electricity. Charged particles moving, whether it's electrons, ions, or charged heads, you could actually create, right, power. Charged electrons moving, charged atoms moving, that's electricity. Cool. Okay, so NT, trigger, right? Excitation releasing the terminal bud, remember that? Okay, and I'm hitting the free as the wind blows, right? Crosses the synapse, right? And then connects to, right? PD can be the receptor channel, right? Open, and guess what rushes in? Yeah. Does a neurotransmitter, does Nate Miller enter the next cell? No, he's just a key. Nah, he's just a key. Okay? Yeah. Pretty slide. I think of you when I make these like backgrounds.